Now we will move to the presentation of Helena Monteiro. She is a technical coordinator of Sustainability Assessment Research Group at Low Carbon and Resource Efficiency Units at R&D of ISQ. Helena Monteiro holds a PhD in Sustainable Energy Systems from MIT Portugal program and a Master's in Energy for Sustainability. With over 16 years of experience, she is a dedicated researcher specializing in sustainability assessment and environmental and economic LCA. Her work focuses on energy efficiency and modeling of environmental LCA for a variety of systems. So, to share the screen. Yes. Now you have the floor.
Thank you, Carla.
Thank you.
Hi, everyone. It's a pleasure to be here with you today. And so let's define success. So I hope to get a smile from you today. So I feel happy about myself. And I hope to get your interest in this topic, even though you might not work on sustainability and sustainability assessment tools. So why is this important? Why is important to have sustainability assessment tools? And specifically, we use them to support the development of new polymers. So as you might know, we use plastics for many end uses. Actually, you are seated on plastics today. And along the last years, plastic production has doubled over the last 20 years. And the trend is to continue. However, most plastics are fossil-based. So we are trying to shift a bit from fossil-based to more sustainable alternatives. And unfortunately, as well, most plastics last very little in use. So many products have short lifespans, and most plastics will end up being a waste in less than 5 years time frame. So therefore, plastic waste is also increasing. And the big problem is that from this plastic waste, among 22% is mismanaged. That is, we lose these plastics to the environment, which cause pollutions to the air, to the water and soil, and this is bad for us as a society. To add to it, despite we talk a lot about recycling, actually nowadays only more or less 9% of all plastics are recycled. So that's a huge thing to try to solve this end-of-life problem of products that are based right now still in the linear economy. So how to solve these problems? For first, we aim to reduce virgin plastics use and control pollution, and therefore reduce plastics waste as well. For that, as a society, we are trying to design these new products for circularity, and one of the strategies is to promote the recycling processes. However, not all plastics are recyclable, as we talk today. And since I'm here on part of REDONDO project, I'm talking you about PEX, which is non-recyclable right now. And however, despite there are many plastics that are recyclable, in reality, we see that very little part of these plastics end up being reused again. And this is due to some challenges, namely the contaminants, some inefficient collection systems or expensive, and also the treatment required for recycling. So to add to it, we should have a way to assess if we should recycle the plastics or not. Therefore, to see if the new plastics, if we will cite it, have the same functionality as the original ones, that is performance, if it is feasible, technical feasible, and lastly but not least, if it is sustainable, because if it isn't, we we might having a problem shifting that we will deal with it in the future. So in REDONDO project, we aim to develop a reversible cross-linked polyethylene as a consortium to be applied in end products such as pipes and cables. And as it was talked today by Professor Bicchiaris, we have functionality requirements such as thermal stability, mechanical properties, antioxidant and flame retardant properties that need to be assured and developed. To do so, the project is also trying to develop a set of bio-based nano additives to be introduced in this polymeric matrix and achieve functional requirements needed. And with that, we aim to follow a sustainable by design approach. So how can we follow this approach? To start with, we need to measure sustainability. If we don't have tools or way to measure what we are doing, we cannot improve it. So we have to assess the sustainability along the development stage to support decision. And for that, we have a set of different tools that were already talked today, such as life cycle assessment, life cycle costing, and social life cycle assessment. So to start with the first one that we are using at ISQ, life cycle assessment, this tool is used mainly to track environmental performance of products along the life cycle. It is a standardized methodology, and we hope to assess the cradle to grave or cradle to cradle of the product. That is to include all life cycle stages of a product. With that in mind, we expect to estimate the potentially environmental impacts along different life cycle stages for the product being studied, namely the RPEX. And to assess this performance, we have multiple environmental categories, namely 16. We have also chosen the PET method, as the previous speaker talked about. And we expect with these 16 categories to cover the 4 areas of environmental impact, namely climate, human health, ecosystems, and resources use. And the goal is, along the project, identify the main hotspots, which are critical areas of environmental concern, and compare product alternatives and drawing some recommendations to our partner for improvement along the projects. We do this analysis based on a collection of primary data on material and energy flows of the production process covered for a determined functional unit that expects to represent the functionality of our product. So, as it was already said, LCA has 4 standardized steps, namely the goal and scope, in which we clearly define the boundaries of the study, the functional unit, we identify a flow chart with all the process steps included, and we assume the methodological choices of the study. And this should be very transparent to allow future comparisons. In the second stage, we collect primary data to cover all these processes, namely material, energy, and waste data that will be used then to assess the environmental impacts. And we cross this primary data with background data from society to complement the analysis. On the third step, the life cycle impact assessment, we use standardized life cycle impact assessment methods, such as PEF, which cover different environmental impacts, that in this case, 16 categories. And we need to have a multi-criteria comprehensive approach because not all categories point the same direction. One alternative may be good in terms of CO2, but may be bad in terms of acidification. So there are some trade-offs that should be considered. And in the last step, we identify these hotspots and provide recommendations for improvements with our partners, and then reassess the process all over again, expecting to have a more sustainable or more alternative with lower environmental impact. So far, along the project, we have been applying life cycle assessment to assess the development of different nano additives and also RPEX synthesis via CS bonds, but these developments are still at lab scale. So for these developments, so far, the generic conclusions is that electricity and energy consumption dominates the majority of impacts of the processes, representing amongst 70 to 95% of these impacts. And this is mainly due to drying stages, heating, blending, and small-scale inefficiencies. If we disregard electricity, since the electricity, when we scale up, tend to have a lower environmental impact or slightly lower environmental impact, we may find a new material hotspots, which are associated with solvent use, acids, reagents, and also feedstocks, such as the previous speaker talked about. Many times the agricultural feedstocks have a high environmental impact that should be considered as well. So some recommendations at this point is to prioritize energy efficiencies of the process steps before the scale up. That is, investing or selecting efficient drying processes, include low carbon electricity sourcing of these processes, and promote some circular economy along the processes, such as solvent recovery or closed loop chemical systems, and also look at the green procurement perspective and have a sustainable sourcing of some key feedstocks. The next steps along the project will be to apply this methodology to assess the RPEX production at pilot and industrial scale, covering the production of different products such as the pipes and cables, and also to provide a comparative analysis with the conventional plastic non-recyclable. However, we already identified some modeling challenges, namely the functionality of the products. We are not sure that the products in the end may have the same functionalities, so life cycle impact assessment is based on functionality. So at the end, we may need to normalize results to have a comparative study. We also have recyclability, that is the number of cycles or recycling cycles that the product is able to sustain may affect the environmental impact of the products. And also we have to model the scale up of these new additives that are still on a lab scales, and that at the end of the project, they won't be at an industrial scale. So we have to do this perspective LCA. To cover another sphere, the economic sphere of sustainability, we are applying life cycle costing, which aim to cover the economic dimension of sustainability and consider different things such as materials, energy costs, waste management. And the goal of this sphere is to support decisions towards the main cost drivers and help partners to select the most viable economic process alternatives prior to the scale-up. We will also compare the production costs of virgin and recycled polymers to support this decision. And the goal is also to identify some of the cost losses along the processes associated with waste and with environmental externalities. Looking to the third sphere, which many times is overlooked, we have the social aspect or the human aspect. We aim to estimate the social risks or comparative social benefits of the proposed developments. And for that, we will use generic and site-specific data, and we will be based on NEP and SETAC guidelines. We expect to support decisions towards this social risk mapping and suggest mitigation strategies whenever we identify some risks and cover different social stakeholders, such as workers, consumers, the community and society, and the value chain actors of the RFX. And the goal is to promote a fair and responsible choices for society. And at the end, with all these three assessments, we expect to understand, give information, and prevent problem shifting from one sphere to the other. So at the end, we expect to have an holistic assessment, which is life cycle sustainability assessment, that integrates these three pillars of sustainability. And therefore, combining these different tools is expected to enhance sustainability of the new polymers under development and also align informed eco-design decisions along the development stage of the project. There are also other complementary tools that are being used and may be used in other projects, such as material flow analysis, which is used to cover inventory data, such as energy and material flows or waste flows, but also multi-criteria decision analysis that will help us to tackle the different criteria that we need to consider and weight prior taking a decision. Lastly, I want to talk about some challenges associated with this holistic approach, such as the answer of the previous speaker. Right now, not only in this project, but in every project, data availability is a key issue, because if we lack sufficient, reliable, and up-to-date data, our analysis won't be robust and won't give good decisions. And also, some substances are still quite new and may lack characterization factors. That is, the impacts are not yet covered. So there are still research to be done in that field. There are also a set of methodological challenges which are associated with careful defined system boundaries to allow future comparability among alternatives, not only within this project, but most important, in the future to compare with other RPECs that may be produced elsewhere and that probably will be compared with our results if they become public. So this contextualization and transparency is highly important to avoid misleading conclusions. And we also should consider regional circumstances, because many times on LCA and even LCC, we take average data and background data, which might not be a reality for the context where we are in, and decisions should be made assuming the local conditions. And therefore, to reduce complex trade-offs such as the environmental, economic, and social sphere to a single metric or one single number, from one way, it's simple, the decision for the decision maker, but it has the risk to lead to misleading decisions because it blends the results, and therefore the decision maker may not be aware of the trade-offs. Therefore, we may be suffering some rebound effects. That's why it's highly important, this transparency, and to have at first these three spheres of sustainability separately, and then try to give as much information to decision makers so they can take an informed decision. Lastly, there are some trends in LCA and life cycle sustainability assessment, which are to assess the consequence of making sectorial change for society. That is, usually we study only our product, but we forget that if our product is truly scaled up, society may change, and that change may induce rebound effects in supply chains that can also be assessed by consequentially life cycle assessments, and also prospective scenarios that support the scale-up of these new technologies and inform this future scale-up prior they be implemented and where they are more economic viable. So to conclude, sustainability needs to integrate the three spheres of sustainability: environment, economic, and social. We can use a different set of tools such as LCA, LCC, and social life cycle assessments. And these are key to guide decision makers on polymers development. The goal is for these three spheres identify the main hotspots and identify which trade-offs may occur so the decision maker has the chance to reflect and take an informed decision. And this information can support eco-design along development stage and prior the scale-up. Lastly, but not least, there are still some methodological challenges that need to be addressed then while addressing those, we can better support these developments, such as the REDONDO project and the new RPECs that we expect to achieve at the end of the project. So that's all from my side. Thank you very much.